Even the most powerful AI models have this hidden flaw, a blind spot that can completely derail their genius. But what if we could teach them a skill we use every single day to fix it? This is the story of how AI learned to search for answers whenever it gets stuck.
So we tend to think of these incredible AI models as, well, geniuses, right? They're capable of really complex step-by-step reasoning. But what happens when that long chain of thought just hits a dead end? All because of one tiny missing fact. And this isn't just some what-if scenario. This is a real quote from a powerful AI, caught in a moment of uncertainty. It hits a wall, totally tripped up by something it doesn't know. And believe me, this happens way more often than you'd think. Okay, so that gets us right to the heart of the problem. The smartest AIs we have, this category we call large reasoning models, have this one significant flaw that this new research is trying to fix. So first off, what even are these large reasoning models, or LRMs? Well, you can think of them as the next step in AI's evolution. They're designed to think a lot like we do, breaking down these huge complex questions into a long chain of logical steps. It's kind of like showing your work on a math problem, but for, well, everything.
But here's the catch. That long chain of thought is both its greatest strength and its biggest weakness. See, if even one link in that chain is based on something the AI doesn't know, the whole process can just fall apart. The researchers have a name for this: knowledge insufficiency. It's like a brilliant student taking a closed book exam. They can reason like a champ, but if they can't remember one single crucial formula, they're completely stuck.
And you might be wondering, just how common is this? Well, check this out. Researchers found that a word like perhaps shows up on average more than 30 times in a single thought process. This isn't some rare glitch, okay? It's a fundamental challenge that's baked right into the system. All right, so if that's the problem, what's the solution? Well, the first idea was pretty straightforward. Just give the AI all the information it could possibly need. But that created a whole new set of problems. The standard approach is this technique called retrieval-augmented generation, or RAG for short. The idea is simple. Give the AI access to a huge external library of documents. Before it even starts thinking, it can read up on everything to fill in any potential knowledge gaps. But it turns out this is a classic case of information overload. The documents it pulls up are often super long, they're repetitive, and they're just packed with irrelevant details. So instead of helping, this fire hose of information actually disrupts the AI's careful chain of thought. It's like telling that student in the exam, hey, here's a messy, disorganized pile of every single book in the library. Good luck finding what you need.
And this is where our hero, Search-o1, steps onto the scene. It's a new framework that gives the AI a much smarter way to find the knowledge it's missing.
The first big idea here is something called Agentic RAG. And honestly, it's a game changer. Instead of dumping all the info on the AI up front, it gives the model autonomy. Now the AI can decide for itself, right in the middle of its thinking process. Hey, wait a minute, I'm missing a fact here. Then it can pause, create a super specific search query, and go find just that one little piece of information it needs. The second piece of the puzzle is just as crucial. It's called reason in documents. You can think of this as an intelligent filter. After the AI runs its search, this separate module sifts through the results, pulls out only the precise, relevant fact the AI was looking for, and feeds just that one tiny, perfect piece of info back into the chain of thought. It completely shields the AI from all that noise. It all comes together in this really elegant workflow. The AI starts its reasoning process, it hits a snag, something it doesn't know. It pauses and formulates a specific question, like, what is the molecular structure of trans-cinnamaldehyde? The Reason in Documents module finds the answer, boils it down to just the essential chemical formula, and slots it right in. Then the AI just seamlessly picks up where it left off, but now it's stronger and more accurate than before. Okay, that sounds amazing on paper, right? But does it actually work? Well, the researchers put Search-o1 through its paces with some seriously tough tests. When they tested it on a set of PhD-level science questions, the standard AI on its own got about 58% right. The older RAG method helped, bumping that score to about 61%. But Search-o1, with its smart, targeted approach, hit nearly 64%, a really clear and significant jump. But that's not even the most mind-blowing part. Just look at this number for a second, 57.9%. So what is that? Well, that was Search-o1's score on an even broader set of graduate-level questions spanning physics, chemistry, and biology. And get this, that score is higher than the average score from actual human domain experts who took the very same test.
I mean, just look at the data for yourself. Search-o1 is sitting at the top with 57.9%. Now look down the list at the human experts. Chemists scored almost 49%, physicists were under 40%, and biologists came in around 37%. By learning how to intelligently search for what it doesn't know, this AI outperformed them all, on average.
So what's the big picture here? Why does this one development matter so much for the future of AI? Well, what Search-o1 really gives us is a roadmap to an AI that's just fundamentally more reliable. It's more accurate because it finds facts instead of just guessing. Its reasoning is more coherent because it isn't getting distracted by a ton of noise, and that makes it ultimately more trustworthy. This is a huge step towards building AI that can help us tackle some truly complex, real-world problems in science, in medicine, and beyond. And that leaves us with this one big thought to chew on. For years, one of the biggest hurdles for AI has been its inability to know what it doesn't know. But now we have a model that can actually recognize its own blind spots and actively go seek out the truth. So if AI can learn to search for truth just like we do, what profound questions will it finally be able to answer next?